In 1876, a 28-year-old German engineer walked into a workshop in Mannheim with one idea and zero investors. He had no degree from a prestigious university, no family money, no connections. He had something else entirely, a method, a way of thinking that his country had been quietly building into its students for over a century. His name was Karl Benz, and what he built in that workshop would become the automobile. Not a faster horse, not an improved carriage, something the world had never seen before. Here is the question nobody asks. Why was it a German engineer? Why not British? Why not French? Why not American? Britain had the Industrial Revolution. France had the finest universities in Europe. America had the resources. But Germany had something none of them had. An MIT researcher, Dr. Hal Abelson, after spending years studying why German engineering produces disproportionate world-changing output, called it one thing: systematic thinking at the foundational level. By the end of this video, you will understand exactly what that means. You will understand why your current study method is producing surface knowledge that evaporates in 3 days. And you will walk away with a 4-step system that German engineering students have been using since the 1800s. A system that turns complicated subjects into permanent understanding. The reveal of how deep this goes and how deliberately it was built is coming at the end. Stay for it. Section 1. The problem with how you study. Here is what happens in your brain the night before an exam. You open the textbook. You read the chapter. You highlight 3 sentences. You feel productive. You close the book, go to sleep, walk into the exam the next morning, and forget 70% of what you read. You do not have a memory problem. You have a method problem. Hermann Ebbinghaus, a German psychologist, ironically, discovered this in 1885. He called it the forgetting curve. Without active reinforcement, your brain deletes 70% of new information within 24 hours. Not because you are lazy, because your brain is efficient. It does not store what it does not use. It treats information you passively read the same way it treats a street sign you passed at 80 kilometers an hour. Registered, irrelevant, gone. Here is what most students do in response to this. They read more, highlight more, make longer notes, drink more coffee. More input into a broken system produces more forgotten information. Faster. German engineering education was built on a different premise entirely. The premise is this: you do not understand something until you can build it. Not explain it, not summarize it, build it. Physically, mathematically, structurally, from scratch. If you cannot construct the idea from zero, you have not learned it. You have only met it. That is not a motivational quote. That is the foundational philosophy behind Germany producing more patents per capita than almost any nation on earth, and why German engineering degrees are accepted as a global standard of competence without further verification. The payoff here is uncomfortable. Most students spend their entire academic life meeting ideas and calling it learning. German engineers spend their time building ideas. That single difference explains everything that follows. Section 2. The first method. Grundlagen first. In German engineering schools, there is a word that governs everything. Grundlagen. It translates directly as foundations, but in practice it means something more specific. You do not move forward until the layer beneath you is solid. This sounds obvious. It is not practiced anywhere. At MIT, researchers studied 2 groups of engineering students learning thermodynamics. The first group learned the way most schools teach, broad survey of all topics, moving forward on schedule regardless of mastery. The second group used mastery-based progression. They could not advance to the next concept until they demonstrated complete understanding of the current one. At the midterm, the groups were identical. By the final exam, the mastery group outperformed by 31%. A year later, in their next advanced course, the gap was 58%. Slow is not slow. Slow is the fastest route that actually arrives. German engineering students spend the first 2 years almost entirely on mathematics, physics, and technical drawing, subjects that feel disconnected from building anything. No applications, no exciting projects, just foundations, drilled until they are automatic. Students from other countries who transfer into German programs in year 3 report the same experience. German students are slower to start, but impossible to catch once they begin. Here is why. When a concept is built on a solid foundation, every new piece of information has somewhere to attach. It becomes part of a structure. It stays. When a concept is learned without a foundation, it floats. It has nothing to connect to. It disappears. Your version of this is simple and brutal. Before your next exam, ask yourself one question for every topic on the syllabus. Can I derive this from scratch, or have I just memorized the answer? If you can only recall the answer without the reasoning behind it, you have met the concept. You have not learned it. Go back, find the foundation, build upward from there. The payoff. Every hour spent on foundations saves 10 hours of confusion later. German engineers do not relearn things because they learn them correctly the first time. Section 3. The second method, failure culture. In 1986, NASA launched the Space Shuttle Challenger. 73 seconds after liftoff, it disintegrated. 7 astronauts died. The investigation revealed that engineers had flagged the faulty O-ring design the night before the launch. They were overruled. The concern was noted, filed, and ignored because the mission schedule could not slip. The culture said, "Do not bring problems, bring progress." German engineering culture says the exact opposite. They have a word for it, failure culture. Literally, error culture. The philosophy that mistakes are not failures to be hidden, they are data to be studied. At the Technical University of Munich, consistently ranked among the top 5 engineering universities on Earth, students are not penalized for wrong answers in tutorials. They are required to present their wrong answers. The professor then uses the mistake as a teaching tool for the entire room. The student who got it wrong becomes the most important person in the session. Stanford psychologist Dr. Carol Dweck spent 30 years researching this exact dynamic. Her conclusion: the students who were taught that mistakes are information, not verdicts, develop stronger problem-solving capability, higher retention, and significantly greater resilience under pressure than students who were taught to avoid mistakes. The brain, Dweck found, literally encodes information more deeply after a confident wrong answer followed by correction. The emotional spike of being wrong creates a neurochemical response that flags the correct information as important. A mistake, processed correctly, is the most efficient learning event your brain can experience. Most students do the opposite. They avoid practice tests because they are afraid of getting things wrong before the real exam. They study only what they already understand because the known feels safer than the unknown. They protect their confidence instead of building their competence. German engineering students hunt for their mistakes before the exam finds them. They do past papers under real conditions. They present wrong answers to study groups. They keep error logs, actual written records of every concept they got wrong, with a note on why and a re-derivation from foundations. Your version: before your next exam, take one practice test, full conditions, no notes. Time yourself. Then do something most students never do. Spend more time analyzing every wrong answer than you spent on the test itself. Do not move on until you understand not just the right answer, but why your brain produced the wrong one. The payoff here links directly back to Section 1. Grundlagen tells you what to build. Failure culture tells you where the cracks are. Together they create something most students never develop: an accurate map of their own understanding. Section 4, the third method, Anwendung. Karl Benz did not draw a theoretical automobile. He built one. In a workshop, with his hands. This is not a metaphor. German engineering education has a structural requirement that most countries do not. Anwendung, meaning application. Every theoretical concept must be immediately applied to a real problem. Not a textbook problem, a real one. A system that could break, an engine that could fail, a bridge that a human being will stand on. The University of Stuttgart requires engineering students to complete a praxis semester, a mandatory semester of full-time professional work, embedded inside the degree. Not optional, not an internship you arrange yourself after graduating. Mandatory, structured, evaluated as rigorously as any exam. A 2021 study in the Journal of Engineering Education tracked graduates from application-integrated programs against graduates from purely theoretical programs across 5 countries. 10 years after graduation, application-integrated graduates were 2.4 times more likely to hold patents, 3.1 times more likely to lead technical teams, and reported significantly higher ability to solve problems they had never encountered before. The reason is straightforward. The brain stores theoretical knowledge and applied knowledge differently. Theoretical knowledge lives in one region, retrievable under calm, controlled conditions. Applied knowledge lives in a different region, retrievable under pressure in unfamiliar contexts when things go wrong. A surgeon who has only studied anatomy in a textbook freezes the first time a patient bleeds unexpectedly. A surgeon who has applied the knowledge under supervision, under pressure, with real consequences, does not freeze. The knowledge is stored where it can be accessed when it matters. Your version does not require a German university. Pick the hardest concept in your current syllabus. Do not read about it again. Teach it to someone who knows nothing about it. If you cannot explain it in plain language to a person with no background, you have theoretical knowledge only. Keep teaching, badly, haltingly, restarting when you get lost, until the gaps fill in. Teaching is application. It creates the second layer of storage. Remember the question from the intro. Why was it a German engineer who built the automobile? Why not British, French, American? Here is the answer nobody puts in a history book. Britain built the Industrial Revolution on speed. Move fast. Scale fast. Deploy fast. The workers were tools. The ideas were assets. There was no time to understand deeply, only to execute quickly. Germany lost, repeatedly. In the 1800s, German states were fragmented, outcompeted, and militarily weak. They could not win with resources. They could not win with territory. So they built something no invading army could take from them. They built it into the minds of their students. The German education reforms of the early 1800s, led by Wilhelm von Humboldt, were not designed to produce workers. They were designed to produce thinkers who could also build. The gymnasium system, the technical universities, the Meister certification, all of it was a deliberate national project to create people who understood things at the deepest possible level. And it worked. Germany produced Einstein, Benz, Diesel, Röntgen, Planck, Heisenberg, in a country smaller than Texas, in a single century. MIT's Dr. Abelson said it plainly, "The German engineering method is not about being smarter. It is about refusing to move forward without understanding. That refusal is the method. Grundlagen, build the foundation first. Fehlerkultur, hunt your mistakes before they hunt you. Anwendung, apply until the knowledge has 2 addresses in your brain. You do not need a German passport. You do not need to transfer universities. You need to adopt one belief. The same belief Karl Benz carried into that workshop in Mannheim in 1876. You do not understand it until you can build it.